So you've had the chance to practice a couple of ideas of ways forces interact with masses, the kinds of different forces that may be involved, and then those ideas that Newton had come up with to say in his three laws. If an object is not changing in its acceleration, it's not changing the way it's moving, then the forces on it must be balanced. If it is changing the way it's moving, then there must be an unbalanced force. So let's see how that acts on a body. If I were to just take something very common, if we just take in this first example, and I want to just take a box and I'm going to move it across the floor. And let's say this is totally an icy floor, and so there's no friction. I'm going to come and push on this box, and this box is going to be, let's say, 5 kilograms, okay, about 10 pounds. And I'm going to push a force on this box that's going to be 20 newtons. Okay, what will happen to that box? So what is the governing equation for this? We've already said the second law of Newton's is that when a force is applied to a mass, it will accelerate. That is a vector, and so is this. Okay, because the force has got a direction, okay, the acceleration is going to have the same direction. The acceleration is always in the direction of the unbalanced force. So the question is, how do we get that acceleration of this mass? Well, we put in the numbers. Okay, 20 Newton force. The mass is 5 kilograms. And the acceleration we'll be able to calculate to be 4. And we're accelerating, so do you remember the units for those? Meters per second squared. Okay, so obviously there was a kilogram force in a kilogram unit in here that when we divided by it, you got the kilogram out, so you can see what's left. A Newton is a force that causes 1 kilogram. Okay, the definition of this is 1 kilogram. What force do I have to push this with so that in 1 second it'll move 1 meter? And if you keep pushing on that, it will then increase by 1 meter every time. So it'll go 2 meters if I keep pushing on that. And if I keep pushing on it, the next second I go 3 meters per second. So that's the definition of a Newton, and why that works out when you divide kilograms into newtons. What's left is the meters per second squared in the acceleration. Fantastic. Okay, now let's go through one more example. Extend that page here. If I have a bicycle, okay, poor example of bicycle, but you get the picture. And I'm going on a street, and I'm doing 4 meters per second. Okay, roughly it's 2 and a little bit more times this is the miles an hour. If you were always trying to wonder how you get meters per second and miles an hour. So 4 meters per second is probably like 10 miles an hour. It's double and a little bit more. So here I am cruising on the little bicycle here. I'm sorry that that's kind of not that convincing. So, and I want to be able to get down here to a stop sign. And let's say I know a certain distance. Let's say this is 30 meters. Okay. Now, the question is, what kind of braking do I need to put on here so that I can stop by the time I get that distance? If I'm going to apply a force on this, I need to get to the end, and it's going to have a new speed, right? I want to get to 0 meters per second by the time I get to that. You may already be saying, wait a minute, we just did this yesterday. I need to figure out what the acceleration is in this case so that I can then figure out what force I'm going to need. As a matter of fact, I've got 2 speeds, I've got a distance, okay? And that you can start to say, what is that kind of equation? So, if I'm going to do this, I'm going to say, what is the acceleration that I need to go this certain distance, and I have my velocities. So which equation do we need? Okay, we need the timeless equation. So, the final squared minus the initial squared is equal to